Lipid 4. We're going to continue with the discussion of those lipids that are part of the membrane. We have introduced those that are forming glycerophospholipids, in which we are using 1 unit of glycerol and 2 fatty acids to make 2 hydrophobic tails and 1 hydrophilic head. Now we need to spend a little more time in those sphingolipids that are using the unit of sphingosine to react with 1 fatty acid. Before we go there, we're going to also clarify that these are called hydrolyzable lipids because you can do hydrolysis of ester bonds and also hydrolysis of amides. And then we will also have those that are not hydrolyzable lipids, like the unit of cholesterol. But all of these lipids will have in common that they will have a high content of carbon, 1 hydrophilic part. In the case of cholesterol, that will be the OH. We have also to include the long hydrocarbon chain. That will be the unit of cholesterol. So we have 3 different kind of lipids: phospholipids, glycolipids, and cholesterol. And now I'm going to spend a little more time in the discussion of the sphingolipids. So for the sphingolipids, we say that the unit of sphingosine, it will contain a primary alcohol, a secondary alcohol, and an amino group. So that is an amino alcohol, and that will be an unsaturated amino alcohol. Let me put the word unsaturated amino alcohol, and that is actually 14 carbons long. We can also do the drawing of the molecule in a different way, and that will be a primary alcohol, is chiral compound. That will be carbon number 1. Carbon number 2 will have the amino group. 3 has also an OH, and in here we're gonna put the CH212CH3. That is the same molecule of sphingosine. So if we compare these two molecules, now we're gonna say that on the amino group, we are going to react with, I'm just gonna make that as a cartoon, 1 fatty acid, and the reaction of a fatty acid. So we will have, that could be unsaturated or saturated, that will produce an amide. On the primary alcohol, we are going to react with a phosphate unit. We call also that an amino alcohol. Amino alcohol, and the product will be an amide. The rest is going to be similar to what it was for the unit of glycerol. So we will still have, as in glycerol, a phosphoester bond. So that will be an amino alcohol. I'm just making one example here. Okay, just one example. So we now have again a hydrophilic head and 2 hydrophobic tails. And if we compare these two, just put those two together. If it was with glycerol, we have 2 hydrophobic tails, and if we flip this to the other side, I'm just gonna put here a P big, that will be the hydrophilic head. And if we do the similar, like in this case, we will have that we also have the same, very similar. You will have the phosphate unit in one side, a phosphate unit. Then you will have the amide on the other side, and part of the backbone. I like to do this as a cartoon like this because it helps the students understand how we can go from these actual structures, from all loss of carbons, to the symbol of having head and tail. So you will have, let's say this one, I'm gonna make this head purple and the head for the glycerol phospholipid green. So for this one you have, let's say here, this green, and now you have 2 hydrophobic tails. Both of these are fatty acids, so that is 2 fatty acids. And when it comes to the one from the sphingosine, the backbone itself has 1 hydrophobic tail, so I'm going to keep that. That's part of the backbone of a sphingosine. That only has 1 fatty acid, so there is 1 fatty acid. If I bring colors, let me just bring 1 fatty acid for that one, 2 fatty acids for the one from glycerol. And then to make a membrane, in a membrane we will have a lipid bilayer. I'm not going to invest a lot of time on the lipid bilayer because I have another video from the iPad videos that you guys need to watch because the time is so limited and constrained for that uploading. So please watch the videos that I have already made from the iPad.